Now we're going to talk about the properties and changes of matter. The first thing when dealing with the properties of matter are physical properties. First, we're going to focus on the physical properties of matter. Physical properties refer to observations, something that you see, you touch, you taste, you hear. Those are physical properties. Chemical properties we're not going to focus on too much because technically a chemical property occurs when something is going through a chemical change. So if it's starting a chemical change where you can start observing that change of compounds or change of molecules, well, we're going to put that in the chemical change category. So let's talk about physical properties. Physical properties are divided into two parts: size-dependent and size-independent properties. Size-dependent, we're going to focus on just three things that are impacted or depending on size. Mass. Mass is dependent on size due to the fact that if I have 5 grams of an object, maybe it's a very small amount. But if I have 5 tons of an object, or maybe 5,000 kilograms of an object, it's going to be a lot bigger than those 5 grams. So as I increase the mass, I'm going to increase the size. In the same way with volume. If I have 5 milliliters of a liquid, well, if I increase the volume and I end up having 5,000 liters, that's going to be a bigger size, okay, a bigger amount. So mass and volume are size dependent. Weight is also size dependent because that has to do with mass. Mass is then multiplied by the gravity. We're on Earth, so the Earth's gravity. So it does stay in that same boat because we're multiplying the mass, which is dependent on size, by gravity. So those three things are size independent. They're impacted, they're influenced by size. Now, size independent properties, there are quite a few of them, but generally what you need to do is just really memorize or remember that there's only 3 size dependent, 3 things impacted by size, and all the rest are not impacted by size, where size does not matter. And the first one is density. Density is mass over volume. Well, we can have an object that is very small and still be very dense. We can have an object that is very big and not be very dense. So size doesn't matter. It doesn't mean that only big things are more dense or only small things are very dense. No, it doesn't matter. Density is referring to how compact those atoms are inside the substance. So size doesn't matter with density. I can have something very small or something very big that could be very dense. Now, solubility. Solubility is referring to can I dissolve a substance at a certain temperature? And really, it doesn't matter how big something is, I can still dissolve it. I can still basically start dissolving that amount of substance at a certain temperature. Same thing with melting and boiling points. It doesn't matter the size, I can still get to that state change going from solid to liquid or liquid to gas. It doesn't matter the size of the material, I can still get it to change states. States of matter. It doesn't matter the size. I can have a large solid or a small solid. I can have a large liquid substance. I can have a small liquid substance. It doesn't matter if I am talking about the ocean or if I'm talking about a little cup of water. Same thing with gas. I can have a small container of gas or a large container of gas. It's still gas. Here's one of the easiest is color. It doesn't matter the size. Here for color, I can have a small red object or a big red object. I can have a small apple or a big red bus. Okay, color does not matter. We're not saying only big things are red and only little things are yellow. No. Color, with color, size does not matter. And then the last one, the ability to attract a magnet. Size doesn't matter here. It can be big or small, and it can still have a magnetic ability. So when we're talking about physical properties, what we're able to observe these characteristics, focus on 3 things that are dependent or impacted by size, and then the rest are not. So if you have any questions on this, which many students do, please ask me, okay, in class on Thursday. Okay, now let's move into physical changes and chemical changes, since we said that a chemical property really cannot exist unless it's starting to go through a chemical change. So we're just going to bypass that one and move into physical changes. Physical changes basically alter the size, the shape, the location of the substance, but it does not change the chemical composition. So if I take a piece of paper and I cut it, I rip it up, I crinkle it up into a ball, I move it around, I rotate it, well, it's still paper. Same thing if I do this with water. If I change the state, I freeze the water, it's still H2O. If I melt the ice cube, I melt the solid water, it's now liquid H2O. If I evaporate, I vaporize, I turn it into a gas. It just doesn't disappear, it is gas water. Okay? So these are physical changes. It's still the molecule. If I take an apple and I cut it into pieces, it's still an apple. So here are some state changes you need to know. You learned solid, liquid, gas. Those were the states. Now if I'm changing the state, that is going to be what we're focusing on here, such as changing from liquid to solid. I'm now freezing. Now the focus here, and something you need to be aware of, is what is happening to the heat energy. Is heat energy going in or is heat energy leaving? So if I'm turning something into a solid, I am pulling away the heat energy from the liquid water. The warm water, I'm pulling away the heat energy, I'm sucking it out. The freezer is going to pull out that heat energy and basically turn it into solid. And the reason for this is because nature, what God has made, is intended to create a homeostasis. So the environment, the air is very, very cold in the freezer. So I put the liquid water in there. Well, there needs to be a balance. So heat is taking out of the liquid water to make the air cold, to make the air warmer. Well, we're kind of cheating because the freezer is plugged in using electricity and we're going to keep it cold. So technically, think about a better example would be a cooler. A cooler, you put some ice in it, some soda in it, and then you put the lid on the cooler. It's not being charged by electricity. Okay, melting, solid to liquid. So heat energy is going into the solid, the frozen ice cream, the frozen water, the ice cube, heat's going into it, and that starts to melt the ice cube. Condensation. This is where it gets a little more deep, a little deeper. What's happening here for condensation is we're taking the hot air, water, so the water is in the air, it's moving very fast, it's heated up, and we're turning it from a gas back to a liquid. This is when we take a cold glass of water or a cold soda can and we place it on the table. And after a few minutes, it starts to have little water droplets on the outside of it. As it gets to get those little water droplets, and the reason for that is because the air around the soda can is warm. The soda can is cold. So the air is warm. Well, we need to create a homeostasis, a balance. So heat is going to leave the air going into the soda can. If heat is leaving the air is going to get colder. And if the air is getting colder, the water around that soda can is moving from gas or slowing down into liquid. So we get these little water droplets around the outside of the can. And remember, the heat's leaving the air going into the can. So the air is getting colder, but the can is getting warmer. And then eventually the soda is going to reach homeostasis, reach room temperature. Now, vaporization is liquid to gas. Basically what's happening here is heat is leaving the stove, going into the water. warming it up, causing those molecules to move faster, and they change from liquid to gas. At the surface of the water, when this vaporization is occurring, this is specifically called evaporation, and that's the common word we use. Now, here's two new ones, desublimation and sublimation. Desublimation is basically skipping the liquid phase and going from gas straight to solid. This is how they make dry ice. So there's no liquid state. We are taking gas carbon dioxide and we are freezing it. We are causing it to be so cold. We are removing the heat energy from it, and we are turning it into a solid. Another name for desublimation is deposition. Sublimation is when we commonly see dry ice reacting. We put it on the table or we put it in water, and it kind of creates that kind of fog machine effect. And what it's doing is turning from a solid to a gas. So heat energy is entering into the dry ice and it's going back to gas. And remember, that's CO2. That is our waste product that we breathe out. Okay, and lastly, chemical changes. Chemical changes are when we actually alter the chemical composition of the substance. Now remember, physical changes, the chemical substance is staying the same, but chemical changes, we're making something new. We're completely altering the substance. So if we have a rotting banana, it's completely being altered. A new material is being made. If I burn wood, the ash, we can't get it back to wood. It is completely changed to something new. If I'm cooking, if I have two chemicals poured together and it gives off a gas, we did the vinegar and baking soda. We put them together, they spontaneously gave off bubbles, and then a gas was created and CO2 was created. So that's a chemical change.